All right, so we're given a 0.2 meter thick plain wall. Temperature on one side is 50 C, and we're told the thermal conductivity is 15, and the other side is exposed to air at 30 degrees, and we're told the convection coefficient is 7. And we're told to find the steady state temperature, which I've labeled here as T2. Okay, so one of the most powerful tools that we have in heat transfer is conservation of it, be it energy, be it power. So in order to use it, we need to define either a control volume or a control surface. In this case, I'm going to use a control surface, and I'm going to do it here at this wall. And I'm doing that because at this surface, if we know that, well, if actually to back up, if we apply conservation, we know that the energy stored is going to be equal to the energy, or rather, the rate of energy stored is going to be equal to the rate of energy that comes in minus the rate that energy goes out plus the rate that energy is generated. Now, if it's steady state, there won't be anything stored. And because I'm doing a control surface, it's infinitely thin and cannot, um, it's infinitely thin. So we can't have anything generated in an infinitely thin space. So we get that the energy in, or the rate of energy in, is going to equal the rate of energy out. So the question then becomes, how is energy coming in? How is it coming out? Well, since T1 is greater than T infinity, we assume that heat is going to be transferring in this direction. So heat will be coming in by conduction, which we can say K delta T delta X is going to be equal to what's going out. It's leaving by convection, which is H T2 minus T infinity. Okay. Um, and so to fill in what we know, we have negative K was 15 times this delta is always going to be, you could call it head minus tail. So it's going to be T2 minus T1 over delta X, the 0.2, is equal to H of 7 times T2 minus T infinity we know is 30, and for that matter, T1 we know is 50. Okay, and so from here it's just a bit of algebra, and we should find that T2 is equal to 48.29. That will be degrees Celsius.